Our speaker today is Stefan Seiter. Dr. Seiter grew up in Southwest Germany, where he completed his undergraduate studies in plant production. He completed his PhD in horticulture at Oregon State University. He is currently an instructor and student advisor in OSU's Department of Crop and Soil Science, where he teaches various soil and agronomy courses, including nutrient cycling and agroecosystems. I practiced that. So I think maybe we need a few more chairs. Yes. Let me get some, I'll just roll them to the back and we'll let Dr. Seiter go ahead and begin.
Let's get everybody seated. You guys want to just get a chair? Whoever wants.
There's one here, there's one there.
There's one here.
We're scared.
Those are scattered.
Yeah, there's.
Just take them to the back. Okay, so we're glad you came.
All right. Is my mic on? It should be. Also.
You've spoken to students, you know how to talk.
I do. I have no trouble with that.
There you go.
Now it's green. Now you can hear me. Okay. Maybe it stays on even, so that'd be nice. Yeah, so thanks for coming. Talk to you a little bit about composting. It's not an area of my research. It's just part of the general expertise that I have in organic farming and in nutrient cycling. So I hope to be able to answer your questions that you have. So we'll talk about a few things here. Oops. That's okay. It has a delay that I'm not used to. Okay. So we'll talk a little bit about compost benefits. First, the process of composting, the different types of composting, and if we have time, we'll talk about how to fertilize with compost. So that's sort of the broad outline I want to talk to you about. So why do you guys compost? I heard there were a lot of hands up. So why you do it anyway?
It's at your house,
Keep the nutrient cycling in place, right? Other reasons? I can't do much about that. Okay, but you're right. The media person was so sure everything is perfect.
Murphy's still alive here.
Okay.
Yeah.
It's on right now, but I don't know for how long. Are there other reasons you compost?
Yes, to responsibly use organic waste instead of just sending it off, in the garbage.
To the garbage, yeah, to reduce waste, yeah. Other reasons you can think of, yes?
To avoid the chemicals of chemical fertilizers and things like.
So just have a fertilizer source that you can what it is in, what's in it, yeah. Okay.
Well, that's just what I was gonna say, is that we tend to buy organic and local. And I figure if it's apple cores and organic whatever that I'm eating, it's gotta be safe. So when I put it in my backyard and compost it, it's gonna make really healthy, safe.
Well, whatever you eat might not be safe, but yeah, I agree with that. Okay, so obviously those general benefits, reducing waste, that's a big one, and that's why we do it at home, and that's also why municipalities do it, and so larger organizations, they want to reduce the waste, recycle nutrients that came up here, improving soil health, and there's so many benefits to the soil if you use your compost for soil health benefit. And it turned off again, so I'm going to quit on this thing. So you all are gardeners. You hopefully know about those benefits of adding soil organic matter. There's a whole bunch of that comes with that increasing soil organic matter. And I'm talking only about, in this talk, about organic matter composting. There is industrial composting that you can compost all kinds of material that are non-organic. And many larger facilities do that. They mix organic matter with industrial matter. The problem is then you really don't know what's in it. And that's why we have these problems with these persistent chemicals in compost and so on. So, but that's a whole different story. So we're going to talk here, home composting, only about composting organic matter. And with all of those benefits that come with that, like higher water holding capacity, nutrient capacity, suppressing soil pathogens, microbial community enhancement, and everything that comes with it. And like I said, at the end, I'll talk a little bit about fertilizing with compost as well. So the composting process, part of the natural cycle of everything, and including us. So eventually we decompose, right? But basically organic matter is basically being recycled back, and the main workhorses in doing that are our microbes, but there are also larger organisms involved. We'll talk a little bit about that, but what you have is something that is relatively fresh, a raw material, feedstock, they call it also, whatever you want to call it, and it goes through a process of decomposition. With our composting, we want to accelerate that a little bit compared to just leaving it be where it is. So we accelerate that a little bit, and then out comes a material that is sort of has a soil-like substance. Basically, that's the finished compost. And in that process, there's also a number of things are happening. Among those is that we release a lot of the carbon back into the air, because those microbes, they use the material as a feedstock to basically reproduce, and CO2 is released in that process, which is why we have so much concern about melting permafrost, right? Because we have all of a sudden we have all of this soil around the world in the northern hemisphere and the very southern hemisphere that all of a sudden gets warmer, and what happens is that we stimulate microbial growth, and with that we decompose the material that is in the soil. So anyway, CO2 is always a byproduct of this that we release back into the atmosphere. So basically we're talking about these living organisms that do their work for us. And when we can think of it as a sort of a food chain process. So we have that organic material, whether that's leaves or food scraps or other things that's organic. And organic is not meant with certified organic, but organic just simply means it has carbon in it. It's a living or formerly living material that gets then decomposed. And so it goes through, this goes through a series of trophic levels, they call in ecology, where basically we have those primary consumers that feed on that organic matter, and they might be very small, like bacteria, or they might be larger, like slugs or other things like that. But the primary consumers are then consumed by the secondary consumers, and the secondary consumers are consumed by the tertiary consumers, and so it goes on. But they're all involved really here in that composting process. It's a lot more complicated than just a simple food chain. It's really a web of interactions here. If you think about these invertebrates, that larger organisms and the smaller organisms in here, the larger organisms, there might be some that feed only on organic matter, some feed only on dead organic matter, some feed only on organic matter that has already gone through the guts of other critters. Others feed on the organic matter, but they are reliant on the bacteria that are inside the guts of the larger critters. So it's quite complex and complicated, but for our purposes, for this composting, just know that there's a lot of different critters involved, and they're involved at different stages of the composting.
Can you tell us where would you put earthworms on that?
Earthworms would definitely be in those larger ones, and they feed here. This is listed in here. I mean, they definitely, the earth or worms, they definitely feed on organic matter. And they would be then a primary consumer of those organic residues. Yeah. But they are also, they're very much after the earthworms, and especially the vermicomposting worms. They're very much after the protozoa and some of these other things that are feeding on the organic matter. So they're actually kind of scavenging off of that material, not necessarily for the organic matter, but for those protozoa and amoeba and all of that. Okay, so the main, like I said, workhorses of this whole process would be the microorganisms. So those that you don't see with the naked eye, that's why they're called micro. And so we're talking mostly of bacteria and fungi. Those are the two big groups. There's one special bacteria called actinomycetes. They get classified differently sometimes. So years ago, they were their own class, and now they're bacteria again, and who knows what happens in 10 years. But they're basically a type of bacteria that looks like a fungi. That's how you can think about it, multi-celled organism. But they have a very special importance to the composting process. That's it, at the end, when you smell a compost and you say, oh, that smells good, that earthy smell, that really is a byproduct of actinomycetes. And you smell the actinomycetes there and their byproduct. So they have kind of a special importance in this whole process. But otherwise, we have bacteria, and we have various kind of molds and other kind of fungal organisms that do most of this work. And each one of these, and if we just split it up into bacteria and fungi, they all have different preferences, and that's why they come in the process at different times, and we'll look at that in a second. But so there are different factors that either favor bacteria or that favor fungi, and this is just one of them. How much carbon is there versus how much nitrogen is in there, and other nutrients. And so one favors more bacteria, one favors more fungi, and that feels probably pretty. You probably know that because if you go into the woods and you dig around, you see a lot of fungi, right? You see a lot of carbon, and that's being decomposed in the woods. So you can think of it that way. But there are other kind of characteristics that are important where and that guides us in part of how we compost. Because the bacteria, they can handle higher moisture. They can survive a fairly low oxygen environment. So when everything is still pretty wet, they can still work there, while the fungi don't really like that kind of a environment. The bacteria can handle much higher temperatures, and that's why they're involved in that process of hot composting, especially in that initial phase when the compost is really hot. And then later the fungi come in when it gets a little bit cooler. And then pH, there are differences on how they can handle a bacteria, like it more in the neutral level, and the fungi can handle very, very acidic type conditions. But so how these preferences guide us in part on how we compost, but they also illustrate to us what's going on exactly. And I'll show a little bit of that in a second. So I talked already. I don't want to spend too much time on this. So when you talk about the raw materials, like I said, I'll just talk about organic materials now, not about any industrial materials that can be composted. But in general, how do you distinguish between different materials? And most master gardener will probably know that. What are two basic type of different materials that you have?
Greens and brown.
So it's one, okay, Cheryl?
Brown and green.
Brown and green, yeah. So that's sort of how we distinguish materials. So one would be those bulking agents, and we call those the brown materials. And so they are usually fairly low in nutrients, And for example, nitrogen, they're usually, not always, but they're usually fairly low in moisture. And because they're bulky and they provide some porosity when you put them all together. There's a lot of air pores basically, and so there's a lot of aeration. But by themselves, they decompose very slowly. And that is in part because they have a very low nutrient content, so not very attractive to the bacteria to feed on it. It's just not enough there. And then the low moisture is also not favoring the microorganisms. So the composting is all about making those buggers, those little critters happy, right? And they like it moist, but not wet. They like it warm, but not hot and not cold. And they like oxygen. They need oxygen so that they can get their colonies going. So those are the three basic things that microorganisms need, and everything in composting is about keeping them happy, basically. So we have the bulking agents, and then we have, as you said, those green materials. They have usually higher nitrogen or higher nutrient content in general. They're usually higher in moisture. And by themselves, again, there's different things that you can use, whether that's garden trimmings or food waste or manures. Those all kind of meet those criteria, but by themselves, they don't really compost very well because they're actually too wet, right? And so if you have too much wetness, it always means you have not enough air because there's always a balance. Either the pores that you have are filled with air or they're filled with water. It's one or the other. But you can't, if it's really wet, you have low oxygen. If it's really dry, you have high oxygen. And the moisture is just basically opposite here. And so they wouldn't do very well by themselves either, because if you put them all together, it gets very dense and very moist. And so then you don't have the air coming in that the microbes need. And then you have a balanced raw material. And those materials, they're sort of in the middle of all of that in terms of porosity, in terms of nutrient content. And they would actually, they do compost by themselves. But we use them then to also to create a better balance between the bulking agents or the green materials and the brown materials in our composting. And when you look at that, there are a few characteristics that are really important to think about in composting. And one is particle size. So how large are the individual particles? And because that affects a lot the aeration. So if you have something very large, that gives you large pores. And so that brings the air and the oxygen in that the microbes need. And you can certainly influence that if you run it through the chipper or if you don't run it through the chipper, if you break it apart or if you don't break it apart. So that's where you come in as the manager of the compost pile to decide on when you need to maybe break something up and when you don't. And the second more really important thing is the amount of moisture that you give in the compost pile or the characteristic that material has. So that again, like I said earlier, it's that balance between moisture and aeration. If it's really moist, you have not enough air. If it's really dry, you have too much air and not enough moisture. So moisture, you can add it. It's hard to get rid of it. Right? You can let it dry, right? But it takes a long time, and you probably don't want to do that. So, but you can always add. So that's sort of where you need to think about that. And then nutrient ratio is important. For home gardening, there's only so much you can do, and so much you want to do. In a professional commercial operation, they take extremely good care of the carbon to nitrogen balance. And so they make very much sure that they have the perfect balance between the two. And again, they want to feed the bacteria, but they also want to feed the fungi. Both of them need different kind of carbon to nitrogen ratios. So that's a whole different story there. But if we look at brown materials, for example, so here's sawdust, cardboard, newsprint listed. And if we look at percent nitrogen, and that's just on a dry matter basis, it's always below 1%. And most of the time, much lower than 1%, sometimes only 0.1% or so. So on the brown materials. And if you look at the wetness, it's always under 50%. I mean, there are some exceptions, like if you have a really wet sawdust, it might have a lot of, but that's exceptional, and even on the leaves. But usually we talk about 10% moisture, 15% moisture, which may sound like a lot, but it actually isn't. 10% moisture is really, really dry. But if you compare that then to the green materials, you can see here, we're always talking about above 1% and often even 2, 3, 4, 5. 5 is hard. But 2 to 4% wouldn't be unusual to have in a green material of nitrogen. And the moisture is always over 50%. And when I say 50%, I say that because 50% feels kind of moist, but it doesn't feel wet. But once it gets to 60%, 70%, then something feels really wet. Yeah. So food waste, for example, 70%. Obviously some food waste is much more wetter, has a much higher percentage, and others is drier, but that's a sort of a good average and feels wet. So that just gives you a little bit sense of where we are with that. So you can make compost in different shapes and sizes and everything. So most commonly we use either piles or bins or windrows. All three work at home. It doesn't matter what you use, it all works. There are just certain rules that you need to think about when you put these together. But whether it's in a pile or whether it's in something that is enclosed, it has some implications. When you close something, there's better insulation, for example, compared to an open pile. But you can certainly use all of those kind of configurations. And when we think about types of composting, we have the slow composting, also called cold composting. We have the fast one, the hot composting, and we have vermicomposting. I'll talk mostly about the first two, because you guys have another conversation with vermicomposters, I think, later in the series. But if you have questions later, I'll certainly try to answer them on vermicomposting. So slow or cold composting, the name says it all. It takes a long time, and the pile doesn't heat up a lot. It may heat up for a little bit, but you're not trying to constantly stimulate that heat to be produced. And that's sort of very common in a home garden, that you do the cold composting method, where you just kind of add material over time, or you mix things together and then you kind of leave it alone, but for a longer time. And you can do that above ground, in a pile or in a bin, or you can do that also in a trench and in pits. You can do that also below ground. There are some advantages to that, but it's a lot of work to create these pits, to create these trenches. So it would be more the exception than the norm. And then above ground, many of you probably have learned that one good method of doing this kind of cold composting is that you start to layer things, that you start basically having a layer of brown material, then a layer of green material, layer of brown material, layer of green material. So that's one way of at least stimulating some aeration into the pile, which will always increase the speed of decomposition. In terms of overall end result and what kind of nutrient value that compost has in cold composting, it does actually conserve some nitrogen. So a well-managed cold composting pile has probably a higher nitrogen content than a hot composting pile. And that is because in this process of stimulating the microbial biomass, and there is a lot of nitrogen basically escapes that pile in the hot composting pile as ammonia gas. And so that's where that all disappears, and it's not in the compost anymore. Compost should not, and I'll talk about that later, but compost is certainly not, shouldn't be your primary source of, or your only source of nutrients in your garden. It could be helping, but it shouldn't be the only source of nutrients. But cold composting has also the disadvantage in terms of nutrients could be a disadvantage because you leave it so much longer exposed. And so if you don't have it covered, you could, and in this case, you can see here a little bit, they have a little bit of protection with some straw over it. And that protects it a little bit from the kind of the elements. And you have it just for exposed for a long time. So there's sort of a balance. What, you know, on one side you lose more, but you also keep more. So if we think about cold composting, you know, it needs little care. It's a big advantage of that. However, it takes a long time. But then you can just keep adding material, and you don't need to turn it all the time and everything. But by just leaving and adding material, the end result will be a material that has a lot more uncomposted materials in it. So it might have little sticks in it and things like that. And that's not a bad thing to add that into the soil. So you don't need to have the perfect compost that's all perfectly soil-like. It's totally fine to have some sticks in the soil, right? And so you have that undecomposed material. It does spare some disease-suppressing organisms. So there are kind of the compost pile is colonized by antagonists to pathogens, and so that is a big advantage of cold composting. And if you think about the biodynamic method of composting, that's a type of cold composting that they do. They are not actually encouraging always the fast decomposition, as opposed to organic certification. Organic certification is always hot composting. Biodynamic is actually a cold composting method. So there's a difference, and there are different philosophies behind that. But the problem here is then, again, while you're sparing those disease-suppressing organisms, you're also sparing the pathogens. And so you're actually, it doesn't kill the pathogen, and particularly important maybe for many of us who don't want to be there hours and hours of weeding, it doesn't kill the weed seed. So that can be a disadvantage. And also the kind of the having the fresher material for a long time then attracts all kinds of critters, also fruit flies, critters, and that's why you want to probably take some precautions against that. So different ways of composting. You know, you can have one pile and do it on one pile, or two piles and do it in two piles or three piles. It just depends on how much you want to get into it. In this 2-year, 2-pile system, you know, you would basically in year 1, you kind of create, you first start with probably a coarse layer on the bottom. So to not have that wet material just sit on the ground right away. So you want to start with a coarse layer on the bottom, you know, break apart longer stems into smaller pieces, and then add basically your fresh material and food waste. And then maybe cover that again with some coarse material, and that's mostly for, you know, not having the critters and the flies on it all the time. And then in year 2, you would sort of, and then you would just leave it. You know, in year 1, you would do that, but in year 2, you would turn it once, and then you just leave it for another full year, right? And only in that 3rd year, you would actually then use it. And then you would kind of use the compost and then start a new mix. It's not the perfect system with two bins, because you have to get rid of the cured compost at the same time when you want to start a new one. So it's 3 bins is probably better because then you can have a separate bin just for the compost that you're using. But it all works, one pile, 2 pile, 3 pile.
I have a question.
Yes.
So, seems like there's benefits to cold and hot composting. Could you say like in the first year or first 2 years, have like a slow compost and then in the 3rd year, do it like a hot compost system where you like, add more nutrients, heat it up to kill off pathogens, but also have the benefits?
It makes it a little complicated because all of a sudden you have a completely different mix of many of the fast decomposable material that the bacteria like is already decomposed.
Okay.
And then, so the mix changes completely. So you do want to have both available for your microorganisms. It will still compost and you might, I'm not sure whether you get it hot.
Okay.
After 2 years, you might not get it hot anymore because there is nothing there that has that kind of accelerator effect on the microbes.
So could you do it the other way around? Have a hot composting system and then let it mature for a couple of years?
Yeah, if you have to, but why? If you do a good job in the hot composting, you don't need to do that. You might as well just use it.
Okay, cool. Thank you.
So cold composting, convenient, but you always have coarser material, which I said is, I think, not that big a deal. If you integrate some coarser material into your soil, it might actually be good in our clay soils that we have in Corvallis. So you have that issue. You always have the issue of critters because you have fresh material being added. That can be problematic. And you have weeds definitely sprouting out of that compost and reproducing and having weed seeds that you then spread all over your garden. So hot composting gives you a faster product. It's because it's more uniform. It's easier to spread then. It doesn't have the odors that if you do something wrong, the cold composting so if you don't have enough coarse material in it, then you get those odors in it. Your weed seeds. So there are definitely advantages to hot composting, but and the last point in terms of reduced pathogen levels, that's why certified organic compost is always hot composted. It has very specific rules. It needs to be for a certain time at a certain temperature. It needs to be turned, if it's in windrows, it needs to be 5 times turned in 15 days. And it needs to be between 130 and 131 and 170 degrees for a particular time. So it's very, very specific in the rules. And the rules actually come from the old EPA standards for sewage sludge pathogen reduction. So they were just converted. USDA simply converted the EPA rules of how to deal with sewage sludge. They converted them to certified organic standards because they were so concerned. When certified organic started, everybody was concerned about pathogens, and that would give certified organic a bad rep if there would be some cases where pathogens actually would be present. So they basically, word for word, they took the EPA regs of the sewage sludge pathogen reduction method and just said, this is what you need to do in organic. And so that's why it's very specific temperature, very specific time, very specific times of managing your windrows, which is mostly how it's done on a commercial scale.
And that hasn't changed.
Hasn't changed, no, yeah. It's all about pathogens.
Yeah.
Everything else is secondary. As soon as there's any human health concern, that always trumps everything.
Sure.
Yeah, that trumps everything. I shouldn't say that. Anyway. So hot composting. So the main drive of hot composting is bringing air into the system and on a continuous basis as much as possible to keep the microbes happy. And so whether that's in a pile, whether it's in a bin or in a short windrow at home, whether that's on a large scale with very long windrows where they have these turners, self-driving or attached to a tractor, or whether it's in a concrete vessel with a mixing rotor, or like they have in the, here they have large static piles. So where you're, where's that, what's that called? The Corvallis municipal composting of the leaves. They have large static piles, but they have aeration tubes in the bottom of these piles and they blow air into it. And so they don't need to turn, basically. I visited some facilities with these concrete vessels and it's fascinating. I mean, everything is automated, moisture sensors everywhere, left and right, large concrete vessels. They make compost, I mean, perfect compost out of not just organic material, but including industrial material. They make compost in 3 weeks. The microbes are so active in that perfect environment. In 3 weeks, they go from totally, industrial and organic waste to perfect compost. It's fascinating. So they really harness that power of the microbes. Nutrients, it requires, like I said, a very careful control of the CN ratio, of the carbon to nitrogen ratio, because you want to, again, you don't want to have too much carbon, you don't want to have too much nitrogen, because you want to keep those critters happy. Overall, like I said earlier, it does conserve less nitrogen. So hot composting characteristics, it's fast, but it's labor intensive. It kills most of the weed seeds and the pathogens, but it doesn't suppress soil-borne diseases. So again, we have these pros and cons between the two different methods here. Hot composting at home, if you think about the process, okay, you build a pile, it's the first step. And when you build a pile at home, you want to have at least 1 cubic yard of material. Otherwise, you don't get the heat. And a cubic yard can be a pile that's 5 foot at the base, roughly, and at least 3 foot high. That's sort of minimum. Or you might have a bin that's 3 by 3 by 3. That's also 27 cubic foot, which is a cubic yard. So you want to be so you want to have at least that much. And that allows things to get warm in the center. And then you can turn the center out, basically. You want to mix, and that's by volume, about 2 parts of bulking materials with 1 part of the energy-rich materials. So brown by volume, 2 parts, green by volume, 1 part, not by weight. Most of us probably weigh your material. But you should think about shredding some coarser materials, and you should think about to not include your very large material unless you have a shredder. So if you have large branches and things like that, you might, maybe cut them up and put them in the municipal bin, because they have those methods and they have hot composting there in a more professional setting. But it's hard to decompose and trying to hot decompose any kind of larger branches and really woody material, unless you have some way of shredding it. And then you always get the recommendation to check the moisture, but it's actually not easy, especially in the beginning, because you cannot squeeze the coarse branches, right? Or the materials. It's hard to do. Once it has started to decompose, then that method is fine. And basically, when you take material and you squeeze it, and it's moist, and there is not a lot of water dripping out, you're about right. That's about right. So that's roughly 50%, which is where you want to be. But like I said, it's hard in the beginning when you don't quite know what's going on. So that's why we have that guideline on the volume part. For commercial situation, they have calculators where every material is in it, and they basically then carefully design their mixes in these large windrows where they say, okay, you need this many yards of this and this many yards of that, and that gives you this CN ratio, it gives you that moisture roughly, and so on. So it's on a larger commercial scale that's done very, very carefully, and they have help with that, with these calculators. So next thing would be turning your pile once you build the pile, and the recommendation is to do it weekly for at least 4, 5, 6 weeks. Every week you turn it at least once, which is not quite organic certification standards where you have to turn it 5 times in 50 days, but for home, that's fine. You know, turn it weekly for at least 5 times. So that would be a recommendation there. And you can see initially it's still all that very rough material. And if it's very dry, you add water to it. But the goal is to have the hot center basically then turned outside. And then the center can then get hot, and then you do that a few more times until hopefully everything has been through 3-4 days of 150 degrees or so. So that would be the goal in the hot composting process. When it's really rainy, we should probably cover it. And you shouldn't expect too much to happen in hot composting in the winter. No, it's just, you can try, but it's hard. You know, we had this composting system at LBCC where I had 3 big, really large bins, and we tried, and it's difficult to do in the winter. So then next step would be curing the compost. Yes.
I did have a question. What would you say, like, the temperature should be outside for hot composting? Like, what's the minimum temperature for success?
You want to be at 130.
I mean, like,
On the outside?
yeah, like,
Ambient.
like,
Ambient temperature, sorry.
yeah.
I don't know, it seems like spring, summer, and fall works just fine,
Okay.
and winter doesn't. That's what. I mean, I don't know how that changes with climate change, but yeah, winter is just really hard to do.
Okay,
Yeah.
thank you.
I've heard of people using hot composting to basically heat a greenhouse. Is that something that you've seen happen, or would you recommend trying something like that?
Yeah, I've seen that in action. Definitely have seen, tubes, flexible tubes in the compost pile, and then going into the greenhouse and heating
Oh, wow.
benches.
Okay, the stuff I've seen was actually within the greenhouse, but that's. interesting that
It
you
doesn't
can
have
use-
to be. You can just have the flexible pipe going outside
Okay.
and going underneath. I mean, it's a matter of logistics.
Mhm.
Obviously, you have limited in how you can turn that pile. You know, when you have plastic tubing underneath or inside. And then, so it's complicated. It's a lot of, most people don't want to deal with it because it's like, yeah, then they cut into into that flexible pipe. And, but I've definitely seen in action many times. Yeah.
What about the compost tumblers?
The compost tumblers. I'm not a huge fan, but it just doesn't seem to be enough volume to really get something really going. And then, usually a yard is a lot of material, 3 by 3 by 3, and to turn that would be it would be hard. But usually, often you only have a cubic foot or so in it, and it's just not really heating up much. Yeah.
I had a squirrel eat through mine.
Squirrely.
Ate through the door, and then it was.
Yeah.
useless.
So the pile will shrink dramatically because a lot of the carbon is going up in the air. You lose a lot of the carbonation material, and because it goes straight up in the air. So you can expect that you have more than half of it will be gone in size. Often you have maybe a third left or so of what the original pile was. So expect that. And there will be, even after those 5 weeks of turning it, it will stay hot for quite some time. And that might, at a lower range, maybe at 80 or 100 degrees, but it won't just get totally cold because you have provided now all of the aeration that the pile needs. But if it's done well, in 3 months, you can use it as a soil material, especially in the summer. I would say in the spring, it gets longer, 6 months. In the summer, you can do it in 3 months. In the fall, you can do it in 6 months again. Or if you start right and then maybe done, depending on when you start. But it definitely, outside ambient temperature plays a big role in how long this all takes. So if we look at the temperature curve of a compost pile, so this is time, and this is temperature, or here you can see temperature. You can see that there is sort of an initial very fast moving up of the temperature, getting very hot, and then sort of it doesn't dip, but then it sort of gradually decreases. And those are, there are different microorganisms then involved in this. And so there's sort of an active stage, and then there's sort of a curing stage later on. And in this curing stage, that's when you have that humus formation going on. So that's when that is happening. And going back to what bacteria like and what fungi like. So when we look at the microbial population, you can see here that the bacteria basically follow almost exactly the temperature curve. So they immediately, they're the driver of this process, especially of the heating process, of that really hotness. It's the bacteria that drive that. But then the actinomycetes and the fungi, they kind of come in then and are mostly here active in the curing stage. And they take care of the more difficult to decompose materials like lignins and more hemicellulose and cellulosic material. The bacteria like the sweets. They like the material that can be very quickly used for their metabolism, because the bacteria themselves have a much narrower CN ratio than the fungi. So they basically, you always want to eat or feed on what is good for you, right? For your own growth and for your own population. And so that's kind of reflected in here. So the quickly to decompose material will be in this initial phase by the bacteria, and then as the temperature goes down, that's when the fungal and actinomycete population goes up. So when a hot compost is not hot, there are different reasons for that. It might be just too dry, so there's not enough moisture. And bacteria always follow the moisture line. So as soon as it's more moisture, you have a lot more bacterial populations, and then they go down with the moisture. And too dry might be because you have too much bulking material in it. Or it might be too wet, and that usually goes along with, oh, it doesn't smell right. And so that's when you might have too much of the green materials in it, right? Or you might have put on too much water. Or if it's just not the right ambient temperature. It's cold outside, and the pile is too small, so the cold temperature basically goes all the way into the center, and it never allows it to go warm. So those are sort of the main 3 reasons why the compost is not very hot. So here's the 3-bin system we talked earlier. Very convenient because you can have kind of add 1 bin and have fresh materials, 1 bin where you kind of is most of the decomposition happening, and where you can kind of have the curing phase, and then the mature compost that you can use over time, you put that in the 3rd bin. You need to make sure that you have, you maintain those bins. It's a lot of work, to be honest, hot composting. It's a constant work. You're constantly filling something, you're constantly turning something. And so that might be fun for some, and for others, it's not so. Because it's a lot of work, even in those 3x3 bins, and that's sort of a convenient size. That's why most people land on that, kind of 3x3, and also about 3 foot high, which is about a cubic yard. And then because you can still turn it by hand, so that's still possible, but still work, for sure. And then ideally for hot composting, you want to have a temperature gauge, because you also don't want to get it too hot. So that's actually very detrimental to a hot composting pile if you get over 170. So then you destroy all the organisms that you have in there. And so you want to, as soon as it gets too hot, you need to do something about it. You might want to spread it, or you might add some water, or you might something that you should be doing if it gets too hot. It doesn't happen too much in hot compost, but especially in commercial applications, it does happen quite a bit, where they need to then have like an emergency meeting with the compost. So I have only 7-8 minutes left. I can stop right here and just answer any questions, or we can go a little bit into fertilizing with compost. What's your prep?
Fertilizing.
I had a question about what
Okay.
you talked about.
Yeah.
One of your charts showed leaves as an option. Another chart that you had showed deciduous leaves that were separate. And then later on another chart, you showed leaves as a brown material.
Oh, good.
So
Attentive.
are they, I've looked at a lot of applications. So which is it? And then associated directly with that is, in my house, which may be similar to other people's, an awful lot of the deciduous leaves become available in late fall, not in March. Maybe that's similar to other people, I don't know.
Well, it depends on what you say, when you say available. I leave my leaves out because I like the protection for the soil.
Right.
And then I rake them actually partially decomposed when they are already decomposed from the winter.
So in
So,
March,
yeah.
you rake them, I get.
Yeah, right.
My house, I don't.
Right.
And I have small
Yeah.
quantities
Yeah.
of spaces, so they're.
So what's your exact question?
Are deciduous leaves green or brown? That was on your chart.
Yeah, I would say they're in the middle.
Which is a great professor's answer.
Always, yeah.
And
Oh, yeah, I
then,
should have said it depends.
that's an even better. I would ask lots of professors questions. And then if the materials are available in the late fall as opposed to at your house, when should I be using them? Because the ambient temperature affects it. I get it. I
Right,
understand
right,
that.
yeah,
I have an answer for that.
yeah,
I
good,
pile them up
yeah.
and then in the spring, when I'm mowing the lawn,
Right.
Or weeding.
yeah,
Yeah.
I start.
Yeah, I collect
eating
them
that.
too, and then use them as when my active compost. So I collect them, separate them, and then I make my mixture I would make my mixture in the spring.
So in a directly related question, you commented relative to breaking up materials. Should I break up the leaves?
No,
No, leaves are small enough to the bacteria
Yeah.
can deal with them on that
yes,
size.
And there's
Okay.
butterfly larvae in
Yeah.
fallen leaves
Yeah.
too, so you're
Yeah.
killing them if you.
you don't even break them up.
Even oak leaves, you don't need to break up?
Yeah, mix them with other leaves. I wouldn't worry too much about it. So compost as fertilizer, I mean, general comments we already heard, we do all of this when we add compost to the soil, we increase organic matter, that increases nutrient holding capacity. However, the individual composts have highly variable nutrient values. I mean, it just depends on what your feedstock was in the beginning, and that will determine then also what comes out the other side. Yes, everything kind of comes sort of toward a certain middle, but it's still, if you use a lot of manure versus no manure, the compost will be completely different in its nutrient value, right? And so the raw material basically determine how many nutrients you have. But in general, you don't have a very high nitrogen content. So if you started out with a chicken compost having 6% of nitrogen in the compost, and if you mix it up with other things and with bedding and so on, in the end, it will still have a very low nitrogen content, maybe 1% or 2% if you're lucky. Potentially, you lose a lot of nitrogen versus phosphorus and potassium. And so then there is certain imbalance that you might create in that. So you need to watch out for that. In general, also, compost is always slow release because you compost it, meaning you got rid of everything that is already easily available in the soil. So you got rid of all that, and what's left is the hard to decomposed material. And that means that whatever nutrients are left in the compost is a slow release one, no matter what. And so we're talking about mineralization, meaning making plant available rate of maybe, anywhere between 0 and 12%. And, I've had that experience, certainly. At the OSU organic farm that I managed for the first 5 years in the mid-90s, we used a lot of horse manure with a lot of bedding. And I had some interesting experience there where some student groups used the compost and others forgot. How can you forget that? But and their crops did so much better in the early season. But then in August it turned around. All of a sudden, the plots from the composters didn't do so well anymore. But from the no, it was the other way around. So the plots from the composters did really well at the end of the season, when finally things started to break down and nutrients became available. But boy, their plots, when I graded them, they looked horrible. of people who composted, because it was just too much bedding. There wasn't enough nutrients in that. It was all carbon. It was no nitrogen. So be very careful, especially on horse manure, because horse owners, they love their animals and they just dump so much bedding in it that the ratio between manure and bedding becomes very highly favored is very high on the bedding side and very low on the manure side. So be careful with the high carbon materials. So it can have almost a negative effect actually on the mineralization rate, because then all of a sudden the bacteria want to decompose that material, but then they grab on all the nitrogen they can get that's already in the soil. So that's a real problem. So it's a negative almost availability. So this shows again that when you compare manure versus compost, and you have the same percent nitrogen, but the mineralization rate in the manure is always faster than in the compost. That's all that shows, and we talked about that already. So this is the trial that they did in Davis. They did a lot of different compost, and this is the different nitrogen content of the different compost, usually between 1 and 3%. So they all had some manure in it. If they have that high in nitrogen, there was an outlier here with 4%. But basically what that shows, none of the compost mineralized more than 10% in a year, in the year of application. And what that basically means, if you think about applying really high rate, so on a talking per acre basis, I know you're on a garden scale, but if I talk about garden, then it would be 10 wet tons, which would be 5 dry tons. Let's say it's a 1% material, and then it mineralizes by 10%. In the end, you have 10 pounds of nitrogen available in that year. What does a sweet corn need? At least 150. So that shows you get 10% from the highest possible rate of your compost. You get only 10 pounds out of the 150 that you need.
Can you briefly explain what mineralization is?
Mineralization means going from the total nitrogen, organically bound nitrogen that's in the green material or in the organic material, and then microbes making that available to produce a type of nitrogen that the plant can pick up in mineral form.
Okay, so basically just making
Plant
nutrients.
available.
Yeah, okay.
Out of organic material. So usually when you just, the plant cannot use an organically bound nitrogen. It needs to go through that mineralization, and then that nitrogen becomes available in mineral form as nitrate or ammonium usually. And that can be picked up by plants, because that's the only, it's not 100% true, but almost the only way a plant can pick up that nitrogen.
Okay, thank you.
So you mentioned in the cold composting process is actually a 3-year process is what you identified.
Until you use it. So it's a 2-year process, but in the 3rd year.
Let's say you have a 3-bin system and you move it in the first year. Is there any benefit to actually sifting out the course and put it back in the first? Can you speed up the usability that way?
Yeah, you can.
And
but it's a lot of work.
how do you tell when a cold compost is ready to use without going negative nutrient on you? That makes sense. That's why, that's the danger of putting in non-compost material ties up available nitrogen.
Yeah.
Nitrogen. So
How can you
know?
tell?
Yeah, how do you know?
The smell is important.
Smell?
Usually a commercial facilities, they often use an ammonium measurement. So they have their compost tested. If the ammonium is high or has any ammonium in it, it's not cured yet. So because the microbes go through a process where they convert the ammonium into nitrate. And so when that's done, then the ammonium is all gone. So, and also ammonium is a problem I have that picture somewhere. And I never said anything about it, and nobody asked me about it. Here, this is a plant that got an uncured compost.
Oh.
Why? Because it had the uncured compost still had ammonium, and that ammonia is toxic to the plant, and especially affects seedlings. So, chemically, that's how a commercial operator would determine when is my compost really cured. They check the ammonia level. But you can smell it also, yeah. We're out of time, but have
What
questions,
is
yeah.
the smell? I mean.
Huh?
the-
Ammonia?
Oh, so it's ammonia.
Ammonia,
Oh.
yeah, you smell that.
That's what.
Especially if you had any kind of manure in the mixed into the compost to maybe get a higher nutrient value compost in the end. If you still smell some ammonia type smell, then it's not done yet.
Can you comment on the compost that they make, Allied Waste makes and sells? What is in that? Is that like commercial? Or is it just yard debris, or what do you know about it?
When I visited the facility and talked to them, it was just yard debris.
Just yard debris?
Yeah.
Okay.
I mean, then you can question that of what is all yard debris and what people put into that, you know, when people smuggle all kinds of things into it and it sits in the road and it gets the drainage water from the cars and it gets mixed into it. And so there's probably oil in it, I assume from the road, because most people put their leaves on the street. So there's all kind of stuff in it for sure. But it is all yard debris, my understanding. Yeah.
So with that same question, I think industrial landscapers, most commercial operations put their stuff in the same place that the city, you know, what you throw in your yard bin. Like if I take a truck and I just drop off tree limbs and everything else, it eventually ends up in the same place, I think, and shredded and mixed. So their question is, when you have typical Roundup, whatever is on everybody's grass and seeds and whatever is in the plants, do you think that breaks up enough in your home composting and also in like commercial operations? Because you're gonna have a lot of chemicals in there too.
Well, you've probably heard of this one chemical, chlorpyrrolate, that's been in discussion for many, many years, and that was a major concern because it did not break down in any home composting or commercial composting, even hot composting. And that's why they were trying to, get rid of that chemical. So there are certain pesticides that do not break down. Roundup, I don't know. I haven't read about it that it doesn't break up. The assumption is that most chemicals will break up. That's the assumption. But and then there are specific ones that do not. But yeah. And there was a lot of discussion for the last 10 years about this one particular one because it was a very common chemical used in home gardens, and it was on grass clippings, and the people composted that, and then they put the grass clippings, the composted grass clippings in the vegetable garden, and all the vegetables died because it was an herbicide basically. So that wasn't so good.
I think you had a question before me. The gentleman in the front, I think, had a question before me.
Yeah.
Yeah, so I've got a chipper, and so how can I add more brown material if I don't have enough? Because basically what I'm chipping up is all green, right? It's a.
No. It's a chipper simply changes the surface area. So if you change the surface area, more bacteria can feed on it. But it's still the same carbon to nitrogen ratio. So if you chip up something brown, it's still brown. It's just you change the surface area, meaning you speed up the time it takes. And there's the higher the surface area, the more bacteria can feed on it. It's pretty simple.
So, but if I needed more brown material, like I needed to go, I didn't have it on my property. What would you use? What would you use?
What about straw?
Doesn't the city
If you
give
have
away
it.
leaves?
I mean, the leaves, like I said, are sort of in the middle. So you can definitely use the leaves. And that goes back to this gentleman's question about what are leaves, right? And so, but the leaves are sort of in the middle. They are sort of that mixed material of slightly green and slightly brown. So it wouldn't be a bad idea to use just use a pretty heavy dose of that. If you can get it for free and for cheap. Yeah.
Okay,
Yeah.
thanks.
Yeah.
Kind of going to, continuing with his question about the yard waste, I'm curious about the municipal water compost, municipal waste compost. And also you've talked about industrial components, and I'm wondering if you could just give a couple examples of what you would consider an industrial component that's getting composted.
I've seen facilities in New Hampshire. They have some chipped plastic and all kinds of things in it. Yeah, I know. It was pretty insane. I mean, I think, yeah, non-synthetic material. You can compost, in theory, you can compost clothing, you can compost, all kinds of non-organic material, yeah.
So with the wastewater, how much is a concern of the compost coming out of the waste treatment plants? How much of a concern is like medications and other things that are, is that something that is less of a concern now than the conversation used to be 10, 20 years ago? Have methods changed?
Of testing?
Or processing or anything that would make that less of an issue with the product?
There's definitely, I mean, the last few years, last two years has been a lot more concern about the forever chemicals. And that testing has changed for sure, that people are starting to look at that at least. And especially sewage sludge is under, or biosolids, like what the politically correct term is now under a lot of scrutiny. And I can tell from my home area in Germany, it's just total disaster. The composters, the commercial composters are getting sued because they were applying that, and they're now told they were supposed to know that, but they had no idea. There was no testing in place, and so there is some pretty, and we're probably just at the start here at US, because I think a quarter to a third of US cropland is receiving sewage sludge.
Well, Albany Waste Treatment has just started providing it on a large scale.
And I don't know how they have changed there.
Dr. Seiter needs to bike
I know I
back
have,
over to.
in 20 minutes, student advising.